Hello everyone, this is another quick video, and this time about this new board that it's almost ready for production. This is basically a PiStorm, and just to kind of compare, this is a original PiStorm, which is beautiful small factor little board that you can use to connect Raspberry Pi as a 68,000 emulator, and actually much more than that, to your Amiga. And of course this works fine with the current version of Minimig, so you can do that, no problem. But I had a couple of questions from users of Minimig regarding ability or possibility of PiStorm to connect this Raspberry Pi that actually it's slightly bigger and has these USB ports here that you need to remove. This is model 3B plus, I believe, if I'm not mistaken. So for this to work, you will need to kind of remove these ports, otherwise it's just a layout of the board. And this is only, I believe, for 3B limitations, so there's not enough space. So to kind of circumvent this and go around, I've decided to design a new board where you can actually, you see there is plenty of space here. Layout is such that you don't need to desolder anything. So this will work just fine. So now on these 3B plus boards are useful without any modifications. So that's a cool thing. And there's plenty of these boards on the market, especially now because they're not in demand. They're kind of outdated and super cheap. So that's definitely a nice thing. But then, since I was doing the new layout, I wanted to make something, I guess, more substantial in size. I kind of like accelerator boards. They're slightly bigger. Just a personal preference. But then, since I have a little bit more of real estate here, I've decided to add a 68,000 on board as well. Because that way you can have this switch here. It's a jumper, but you can add just a flip switch. And basically, you can switch between 68,000 and the PiStorm without a need to open up your Amiga case or Minimig case, because once the case is buttoned up and all everything's inside, it's kind of like takes a lot of time to remove these feet and remove the PiStorm from the case and add 68,000 inside. And I personally like to switch between 68,000 and PiStorm because sometimes there is a piece of software or a game that works better on 68,000. Sometimes I want to use original CPU just because I can. So for that reason, this is why this little board was born. And of course, since PiStorm is fully open source project, the PCB, the Gerber files, schematics and everything else will be publicly available on minimig.ca. So if you want to assemble the board yourself, you can. I also will have these boards produced here in my workshop. So anyone who wants a PiStorm for Minimig will be able to get one. I'll try to get the best possible price. I'll try to produce this in volume, so I hope that will be good as well. What else I can say? So basically there's a couple of things here that are added comparing to the original PiStorm. The first one, you'll have LEDs for 3.3 volts, 1.8 if it's in use, and 5 volts. There's two LEDs depending on your choice. If you choose 68,000, this one will be on. If you choose PiStorm, the other one. So basically you can just look at the board and see which CPU is in use. Not super necessary, but I mean, it's a nice detail. These are some of the control signals, but actually in the final version that I'm going to submit today, you will have signals for halt and reset for PiStorm and 68000. The way it works, the way I decided to keep it as a working board, and I still need to do the testing before I put this into your hands, but initially this is a fully operational prototype, and I've been using it for a week without a single glitch. But final version is coming, and the way it works, the 60000 will always be on, but when you choose PiStorm, the halt and reset pin will be kept active low, so the CPU will just sit there and behave on the bus. Unfortunately, there are pins here on the CPLD for reset and halt, but I mean, this is not really a CPU, this is just a CPLD having CPLD firmware, and I don't think holding these pins low will halt PiStorm at all, because it's not designed to do that. I don't believe so. If I'm mistaken, you please correct me, but this is what I'm seeing, and I haven't had the chance to look at the code in the CPLD for the CPLD firmware, and this might be changed, so you can inhibit the functionality of the subsystem by holding some pins. But for now, the way it works, once you choose PiStorm, the PiStorm power supply will be disabled, this 3.3 volt supply, and the whole PiStorm system will be offline, and 60000 will be active, and the rest of the board will be used just as a pass-through. So that's that. So depending on what you use, if you use PiStorm, 68000 is active but on halted, and if you use 68000, the subsystem is off, and 60000 is working and working as a pass-through. And so far I've been testing this, it works fine, and yeah, I mean, you know, I'll just do it for maybe a week, intensive testing, and see if there is anything that I'm missing. I improved I'm going to show you now, I know this is dirty and quick way of recording. I should do this more, I guess, professionally, but nevertheless, okay, I hope this will do without sliding off my camera stand. So what we're looking at here is the final version that I will produce. So what's different about this final version is that I add a couple of things. I improved the decoupling a little bit. So here we have inverters, so signals are showing as active, even though they're active low. So when you see those LEDs up and running, let's say 68000 reset or 68000 halt, you will see that. The same thing goes for Pi halt and Pi reset, but doesn't really, it will show as inactive here just because I can, I guess, but as I said, this functionality is not implemented in the CPLD as far as I know, but just kind of to eyeball and see that these lines are active low, I've still kept it, even though it's not functional. It's more of a, you know, here to see, you know, these lines are active low, and that's that. And you can expect these to be active low certainly when PiStorm is deactivated, which is to expect. And once PiStorm is active, you'll see these two signals being active low. So you'll have, even though active low, I said they will be on. These LEDs will be on because I have an inverter on the other side for the signals. So that's that little improvement. I also added a couple of information about the version and the guy who invented PiStorm. And name of the board is PiStorm68K because it has 68,000 on board. And you can see on the other side there is open source logo because the board is going to be open source, published as open source as it should be, being PiStorm. And yeah, I've actually added a liberty of I had the liberty of adding the AmiCube logo here because I will ship these with AmiCube boards. And by the way, I have a wonderful follow-up and update regarding AmiCube. Maybe this video is a good opportunity to kind of talk about AmiCube with large FPGA that will support AGA. Board is, by the way, kind of ready. Not kind of, but it's ready for the first prototype. I will submit the Gerber files for the board maybe in a day or two, and then we'll start testing. The goal for new AmiCube, sorry, this is a little bit off topic, we're looking at the PiStorm, but I will load the 3D model shortly. But long story short, the new AmiCube board will have large Spartan 6 capable of running AGA. Will have ability to run soft 68,000 and real 68,000, also AGA core as I mentioned, and the biggest improvement and change, something that I've been working on for months, is the 2 floppy disk headers for the real floppy. So what is Amiga if without a real floppy disk? In my opinion, that's a must, having a real floppy. So this new AmiCube first version will have that as well. So and we'll use that board for porting the software, AGA core, and there will be a lot of FPGA Verilog development there. It's not going to be trivial, but I think I have a good understanding of all the moving components and what needs to get done. So we'll get there. I'm hoping that this first layout for AmiCube, I'm calling it AmiCube 100, will be good enough to port original Minimig core and start from there and make sure that we can, have functional Amiga computer. And once that's if that's true, first of all, if it's not true, then yet again I'll need to change the layout, pin out, maybe pull some pins out, up or down, depending on certain parts of the process. But from what I can see, it should be fine. I went through all this Spartan 6 documentation, and it seems like I covered everything. So that's that story about coming AmiCube, and I'm going to share a 3D model shortly. But that's why I added AmiCube logo here, even though it's a PiStorm, as clearly says here, just because I want to have the same kind of package, some branding for people who buy AmiCube system. So that's about that. I will send the Gerber files today, and I expect this kind of hopefully final version to be ready within I don't know, maybe a week, and then one more week to test this thoroughly and try to break it somehow, and try to find any problems. Hopefully none, but if I do, then I'll need to have another cycle and then have the final version. But I'm quite confident, looking at this prototype that I was using for a week now and abusing it in any sense, increasing the clock above 60 megahertz and all these sorts of things. Seems like it's in pretty good shape, I would say. I mean, it is PiStorm after all. I use original PiStorm schematics, and I don't expect some major surprise there. Okay, now I'm going to load the 3D model for a new AmiCube. I think that's a big deal project. All right, and let's look at AmiCube now. This is AmiCube V1 or V100, as I call this board internally. And first things first that you will notice is this big, beautiful Spartan 6 here, having slightly over 100,000 LEs, which is same class of FPGAs, I would say, as Ultra Cyclone 5, minus SoC. This thing doesn't have onboard some ARM or RISC-V subsystem. It's just a fabric FPGA, but it's so big for the purpose of recreating Amiga that it's more than we need. Actually, you can put here everything you need to kind of recreate these classic systems, and this will be good enough for quite a long time. Second thing is this floppy disk subsystem, and basically what we have here, we have particular level shifters that I've choose for this translation between 3.3 and 5 volts, and I'm not using same CBDDs because these are intelligent shifters, bidirectional, and this should be better choice than anything else, I think. We'll see how that goes, famous last words, but once I have the prototype I'll see that myself. Here you have some LEDs for all the different power levels. This board is kind of complex FPGA board with a lot of different juices running from 12 volts, 5 regulated, 3.3, 2.5, 125, and there is a standby power coming from ATX because it is ATX board after all. And then all these signals here for debugging floppy, we have I kind of separated this subsection for the DF0 and DF1, so you can see select signals, motor 0 and motor 1, and ready 0 and ready 1. I have some internal logic here that makes sense to me, and it's done discretely with the transistors to kind of choose which ready signal FPGA is going to read. This can be simplified in the future, but this is something that makes sense to me, and time will tell if this is a good choice or not. But basically you can look at this thing and you can see what your floppy is doing real time, and it's kind of beautiful and blinking lights, and it's kind of cool. So also you'll have detect signals. Even though these are active low, as I said, I inverted these using these little inverters, so you can see when they are active, you'll see them active as a high. So it's it breaks my brain a little bit if I try to debug something and I'm looking at the LEDs and I'm looking at the LEDs that are actually off to acknowledge they are on. So that's kind of just a little bit of tiny little change that may help within first couple of months of improving further these floppy interface and debugging and so forth. Although I must say, at this time it's fully functional. I have actually 100% how can I say, functionality and reliability at 28 megahertz when I'm running CPU at 28 megahertz, and if I run at the original 8 megahertz, 7 point whatever it is megahertz, then sometimes I have some discrepancies with the floppy, and this is something I will definitely need to debug further in ISC. But I'm quite satisfied because at 28 megahertz I kind of was able to get all the timing and all the signals in line, and I'm sure that everything is fine. Other than that, it's constraints and Verilog. Additionally, in Verilog, I'll be able to adjust anything. And once this is working, then even further improvements can be made. So at least we'll have a platform with a big enough FPGA to kind of do proper development, because right now Spartan 3 is dying. I mean, it's 90-something% full, and the optimization is impossible. Even the timing is impossible. Everything is kind of like so tight and hanging off the cliff that proper FPGA development, and aficionado FPGA developers out there, you know what I'm talking about. Once you get to almost use all the fabric on the chip, it's getting very difficult. So this thing will give us some space to breathe. Another thing to mention, there is not much difference between Spartan 6 and the latest Spartan 7 in this 100K form factor. At some point I will flip to Spartan 7, but that will take another project for porting everything from ISC to Vivado, which will be project of its own. So that's why I decided to go with Spartan 6 now. And at some point when there is a need, we can, you know, obviously it's the also Xilinx part, it's Verilog stuff, it will be fairly easy to move to Spartan 7, and that will open up some new possibilities as well. We can even think about, I don't know, a Zinc maybe, or some more advanced Xilinx parts that we can use just to kind of be future-proof. But this thing, for where we are, it's more than enough. It's a modern part, still produced, supported by Xilinx or AMD, and it's definitely future when it comes to Amiga FPGA emulation. I mean, it will open up the gates to do proper development for all of this stuff. Chip itself has about 600 something I/O pins. Most of them are all-purpose, multi-purpose I/O pins, and I'm just going to show you the pin out. I mean, these are the pins. Not all of these are. Some of these are power pins. Some of these are for clock or whatnot. But a lot of these are, like, majority of these are just I/O pins we can use for all sorts of peripheral connection with, I don't know, maybe Ethernet card, or we can do Zorobus in the future, so you can add some cards to your Amiga and things like that. So quite a formidable part that will give us a workbench for, no pun intended, for FPGA development here. So yeah, it's, as I said, it's ready, it's routed, it's passing DRC, seems fine. Now it's time to spin up the board, to do some prototyping, and I'll keep you posted about this thing once we have the workbench screen up and running, or that at least insert the disk animation looping. Then it's going to be a big deal. I'm going to share that on the social media, on the Minimig website, and pretty soon after we'll rapidly do the porting of the existing AGA core, and that will be fantastic. So this is another thing. So this is going to be the board that will come together with AmiCube, and that's why I actually slapped the AmiCube logo here, just to kind of be consistent and have the same branding. But it will be a perfect match. I'll do the same color of the PCB, so if you let's say order a board in purple, you'll get a purple PiStorm and that sort of thing. So also the logo here will be done in gold, Henning immersion, or how it's called, same as AmiCube board. When it comes to the design of the PCB, there's slight similarities to Minimig, but I mean, it's a totally different platform using different Spartan chip. And as you can see, I'm replacing all the parts of Minimig, and replacing everything with the brand new layout and brand new stuff. This is still pretty early. Most of these things will be changed. What needs to get replaced is also this old ARM thingy. It's been sitting there for I don't know how many years now. There's a better, faster parts. Also, this can be completely replaced by virtual ARM subsystem inside of this fabric, which is quite formidable, as I said. So that's another thing we can do. And yeah, I think that's the current progress. There will be a lot of changes coming, a lot of improvements, but as I said, once I have the prototype here in the office, further and rapid development of AGA core can start, and that's most important part. We'll have FPGA system that can have the different CPUs, including PiStorm, and have AGA, and most importantly, floppy. Because what is Amiga without the floppy sound and using your old floppies? That's, in my opinion, that's phenomenal. Again, thank you for your patience watching this short video. Sorry for my quick and dirty way of recording and producing these videos, but just don't have enough time between designing the systems, having the job, full-day job, dealing with the kid and all those sorts of things. This is the only format I can afford right now in terms of time, so I just quickly record this stuff and keep you posted. So stay tuned, check minimig.ca from time to time. Within a week or two I'll have these PiStorms ready for Minimig and AmiCube. So hopefully you'll get some fun out of this new project. Talk to you soon. Subscribe, like and share, and see you soon. Bye bye.